In this video, I'm going to talk to you about enzymes. So let's first start by talking about what enzymes are. Enzymes are proteins, therefore they're made of amino acids. Enzymes are a catalyst. They're used to accelerate a reaction, a chemical reaction, by lowering the activation energy of that reaction, and we'll talk a bit about that. They're not permanently changed during the reaction, therefore they can be reused over and over and over again, hundreds or even thousands of times. Names of enzymes oftentimes end in ASE, like lactase and lipase. And you can think about, if you think about those two types of enzymes, you can kind of figure out what they do. So lactase, if you know anybody who's lactose intolerant, that means that they don't produce the enzyme lactase, therefore they cannot break down that milk sugar. And lipase actually breaks down lipids. Enzymes, as you can probably tell a little bit so far, they are specific. They only work on one type of reaction. So lactase only breaks down lactose. It doesn't build it up. It doesn't work on any other type of molecule. It is very specific to that one type of molecule. Lipase only breaks down lipids and does not build them up. So enzymes work by, like we said, by reducing the activation energy. So you can see on this graph on the y-axis, we've got a measure of energy, and on the x-axis, we actually have the progress of the reaction. So before we ever have this reaction occur, we have an enzyme that's present and we have a substrate that's present. The substrate is the thing that's going to have the work done to it, and the enzyme is actually going to help to do that work. So what's going to happen is this substrate is going to plug into the enzyme like you see here, and as soon as it does that, this energy that has to be overcome is reduced. And what happens then is this substrate can then go through the process of becoming the product. So this is this substrate, also called the reactant, and the product is what is actually made. So without the presence of this enzyme, this substrate would have to overcome this huge amount of energy. It's very much like striking a match. If we were in class, I would hold a match up in front of you and I would say, okay, will this match light by itself? Well, obviously it won't. So we have to put in activation energy. That's why we take a match and we actually strike it against the box that's got the rough structure. We're actually putting activation energy into that, and once we get enough energy built, then that reaction can take place. So the catalyst in the case of lighting a match would be striking it against the striker on the box of matches. So we would actually be putting in enough energy to get it over that activation energy. So the activation energy is the amount of energy, it's the difference between the amount of energy found in the substance all the way up to the amount of energy that has to be overcome. So from here, from this line to this line, is your activation energy. And you can see when this substance, once this substance reacts, it's the amount of energy in the products are actually less than what the substance that it began with had. So what's happened in this situation is energy has been released, and that energy has either been released in the form of light or heat, typically. So enzymes work by weakening the bonds, which lowers the activation energy. So how do enzymes work? So let's talk specifically about enzymes that digest molecules. If we're going to digest something, we're going to break something apart. So here we've got a molecule of sucrose. So that's this whole complex here. This is the reactant, otherwise known as the substrate, and this is sucrose. That's an example of a substrate or a reactant. And this odd-shaped thing down here, this is sucrase. The ASE indicates that this is an enzyme that actually works for sucrose. And you can see we've got the active site here. The active site actually matches the shape of the sucrose. So this sucrose will fit right into that location. The active site is where the action in an enzyme actually takes place. That's where the work is actually done. So what happens is the enzyme and the substrate will bind together just like so. And you can see the bond is still there. We've still got this bond right here between the two parts of this molecule. What we're going to do is we're going to take sucrose apart into its two parts. Well, once it's in the enzyme actually lowers the activation energy, and that one molecule can be broken into two. And in this case, sucrose is broken down into glucose and fructose. And then once that occurs, you can see that the bond has been broken that was here. What happens then is the enzyme releases the products. So in this case, glucose and fructose are the products. And you can see that the shape of sucrase, the enzyme, is exactly the way it was when we first started. So the shape of the enzyme is not changed during the as a result of the reaction. So this enzyme can then take on another sucrose and break another sucrose into glucose and fructose hundreds or even thousands of times. So enzymes can also work to synthesize molecules. If we're synthesizing something, it means we're putting it together. So in this case, we have two reactants. Excuse me, both of these reactants are going to come into this enzyme. And again, you get the enzyme substrate complex, which is the enzyme and the molecule or molecules that are having the work done to it. Once they enter the enzyme, they are then, in this case, they're fused together and we end up with a product. So once that fusion takes place, excuse me, because we're synthesizing, the product is then released from the enzyme. So enzymes can either build up or break down molecules that would not normally do that on their own. So factors that affect enzyme activity are things like extreme temperature. So if we take an enzyme and put it in an environment that's a higher temperature than it's used to, what will happen is that enzyme becomes denatured. The bonds in the enzyme, the hydrogen bonds in the enzyme end up breaking apart the molecule. So if it's supposed to look like this, what happens is the site, the active site where the molecule would fit into there, ends up deforming, and that's why we call it denaturing. We have an unfolding of the enzyme. So the location or the active site where the reactants are supposed to be able to bind can no longer bind or cannot bind as well. So in high temperatures, enzymes can become denatured. In low temperatures, the enzyme is not necessarily affected, but the movement of the molecules is actually slowed. So you have less of a chance of the enzyme and the reactants coming in contact with each other. So differences, different temperatures than the enzyme is normally located at can actually have an effect on the activity. pH is another factor. If you have an increase or a decrease in the optimum pH of an enzyme, it can also denature the enzyme, so it can break the bonds, changing the shape of the enzyme. The reason why I say optimum pH is because there are some enzymes that work really well at really low pHs, like for example, the enzymes in your stomach work really well, really well in a very acidic environment. So the pH of your stomach is very low. If we were to take those enzymes and put them in a different location in your body that has a more neutral pH, excuse me, if we put those enzymes in a position in your body or a location in your body that had a higher pH or a more neutral pH, those enzymes would not be as effective because they would be denatured. So if we decrease the pH, that means that the environment is becoming more acidic, whereas if we increase the pH, the environment is becoming more basic. The best way to remember that is if you put acid and base in alphabetical order, and then you draw a number line from 0 to 14, you're going to put the word acid over the 1 to 7 side. You're going to put basic over the 7 to 14 side, and that will always help you remember which side of the pH scale is acidic, which side of the pH scale is basic. And that's all I have for you on enzymes. If you have any questions, come see me in class.